Hello, I'm going to talk to you guys about nitrogen fixation, the processes, the types of nitrogen fixation, why it's important, and why you should care about it. So first, what is nitrogen fixation? So a general definition is when atmospheric nitrogen is converted into ammonia, and these processes are carried out biologically as well as artificially. So a fun fact is that 70% of our atmosphere is made up of nitrogen. So why is nitrogen fixation important? Well, it helps with plant growth. A big part of this is the nitrates that are absorbed by the plant's roots in order to promote growth and development. This benefits us because plants are a food source for many, and of course are a big role in photosynthesis, partake in photosynthesis. So that's really important for us, and it also helps maintain the nitrogen cycle. So a quick overview of what I'm just going to go over in this video are, again, the types of nitrogen fixation. So in this picture, there are a lot of arrows pointing around. But the big takeaway is that the whole start of this process is taking nitrogen from our atmosphere and turning it into nitrates that can be absorbed by plants in the soil. So a quick history of the biological discoveries that were made. In 1838, discoveries were made by Jean-Baptiste Boussingault, and in 1880, processes were discovered by Hermann Heilgro and Hermann Wilfarth. Then in 1901, they were fully developed by Martinus Virchow. So again, these biological processes were discovered and process developed by these scientists, and it wasn't until 1909 when Hermann Fritz discovers how to chemically fix nitrogen. This is where industrial processes are coming into play and the production of fertilizers. And so we know that fertilizers are not the best for our ecosystems, our plants, but nonetheless, they were created and brought into this process. So there are 4 ways to fix nitrogen. The first is nitrifying bacteria. So bacteria living in the soil help fix nitrogen by taking it from the air and turning it into nitrates. So again, that's the main general idea of nitrogen fixation and what is happening. So how do plants benefit from this? Well, they benefit, of course, by absorbing it and taking it in for nutrition. So this is how the plants get nice and strong and grow to be lovely plants and trees. And the legume family naturally have these bacteria stored in their nodules. So a picture here I included was the roots of a legume plant, where you can see there's little bubbles, little nodules, where those bacteria are living in. So they naturally have them there that help fix the nitrogen. Then the second way is decomposers that are living in the soil that break down the waste and return nitrogen back to the soil as ammonia. So then this ammonia is turned into nitrite, where the nitrifying bacteria take over living in the soil and turn the nitrite into nitrate, where it is absorbed by plants. The third way is lightning. So when it rains and there's a storm and lightning strikes, there are chemical reactions taking place in the atmosphere. So nitrogen reacting with oxygen creates nitrous oxide in the atmosphere. Then the nitrous oxide reacts with oxygen and then dissolves with rainwater. So it mixes in the air, falls to the ground and into the soil and creates nitric acid. And the nitric acid and the rainwater are seeped and absorbed into the soil, creating abundance of nitrate in the soil. So this then creates the nitrate where it's absorbed. The big idea here is that the nitrates are being absorbed. It's a repetition, I know, but it's the cycle, and this is just the processes in which this can take place. And the fourth way is in marine ecosystems. There are blue-green algae that fix nitrogen. So like here on land, with the nitrifying bacteria living in the nodules of legume plants in the soils, there are these algae that fix nitrogen in the water. So it's the same process in the water as it is on land, where the breakdown of waste is turned into ammonia, and that ammonia is turned into nitrite, and the blue-green algae then work to turn the nitrite into nitrate. So then from those processes come the artificial fixing, the industrial processes of where there are burning of fossil fuels, which adds nitrous oxide into the atmosphere in abundances and excessive amounts. And when it rains, the nitrous oxide is dissolved in the rainwater, creating nitric acid. And then the abundance of nitrous oxide leads to the excessive amounts of nitrates in the soil. So the excessiveness is what throws off the ecosystem. It disrupts the balance of how much nitrates are being created in the soil. This creates very acidic soils, which declines the health of plants and bodies of water. So in conclusion, how can we do our part in reducing fossil fuels since they play such a big part in creating excess nitrogen in our ecosystem? Well, the first would be advocating for legislation to create policies for companies to limit excess nitrogen production. And of course, just staying informed and understanding the importance of maintaining a healthy balance of nitrogen in our atmosphere to better our environments and keeping our ecosystems happy. Thank you very much. That was my presentation. Thank you for listening.